AP Style Free Response Problem 11. At 2200 degrees Celsius, the Kp for this reaction is 0.050. We have N2 plus O2 produces 2NO. What is the partial pressure of NO in equilibrium with N2 and O2 that were placed in a flask at initial pressures of 0.8 and 0.2 atmospheres? Write the Kp expression for this reaction and then make an ice table to solve for X. All right, so let's first write a Kp expression. Kp is equal to PNO squared divided by PN2 times PO2. Now let's make our ice table. So let's focus in over here. We have N2, O2, and 2NO, and then initial pressure, change in pressure, and equilibrium pressure. So we're told that initially we have N2 and O2 that were placed in a flask at initial pressures of 0.8 and 0.2 atmospheres. So N2 is 0.8, O2 is 0.2. We have no NO to start out with. Based on the stoichiometry, N2 decreases by an amount X. So at equilibrium, we have 0.8 minus X. O2 decreases by an amount X. So we have 0.2 minus X. And NO increases by an amount 2X based on the 2 as the coefficient. So at equilibrium, we have an amount 2X. Now let's take these equilibrium values and go put them into our Kp expression. So we're told that Kp is 0.05. The pressure of NO at equilibrium is 2x squared divided by N2 is 0.8 minus x. O2 is 0.2 minus x. So this is a bit messy, but I multiply both sides by the bottom of this fraction. So I have 0.050 times 0.8 minus x times 0.2 minus x. And then the top of this fraction is 4x squared. I also subtracted it to the left so I could set everything equal to 0 because I need to use the quadratic equation here. Now there's a couple of steps to get from here. So from here to here, we're multiplying this binomial, or these two, we're multiplying these together. I don't know if you remember first terms, outside terms, inside terms, last terms. But that's where we get this from. And then from this step to this step, we distribute 0.05 to all three terms. Okay, and then simplify. So you get a quadratic equation that says 0.0080 minus 0.050x minus 3.95x squared is equal to 0. Now you need to look up the quadratic equation if you don't know what it is, or maybe you have a program in your calculator that you can use to solve a quadratic equation. Either way, you need to solve a quadratic equation here to solve for x, and we get a value of x of 0.039. Okay. Once we know x, we need to go back to these equilibrium equations that we wrote here to solve for the pressure, the partial pressures of the NO at equilibrium. Now, the question actually just says, what is the partial pressure of NO in equilibrium? So I don't know that we need to find N2 and O2, but for the sake of completion, we did. So for NO, it's just 2 times X. So 2 times 0.039, which is 0.078. N2, 0.8 minus X, so we get 0.76. O2, 0.2 minus X, we get an equilibrium pressure of 0.16 atmospheres.